Hi guys, welcome to Learn with Kani YouTube channel. This channel is all about learning concepts and solving problematic questions related to civil engineering. So please support me by subscribing to my channel so that whenever I upload a new video, you get notification and you won't miss out to watch my video. So today in this video, we are going to see how to solve problems related to strain energy due to bending. Before moving on to the problem, first let us learn some basic definition, formula and how to approach, that is the procedure to solve the problem. So, first of all, what is strain? Let us learn the definition of strain first. Any element in a material subjected to stress is said to be strained. So, strain is the deformation produced by stress, and the strain is denoted by the symbol E, that is small e, and then types of strain. There are four types of strain, that is tensile strain, compressive strain, shear strain, and volumetric strain. Tensile strain, it is denoted by the symbol ET, which is equal to change in length by original length, where L is equal to L plus del L. And then compressive strain, it is denoted by the symbol EC, which is equal to change in length by original length, where L is equal to L minus del L. And then shear strain, it is defined as it is measured by the angle through which the body distorts, and it is denoted by the symbol ES, which is equal to n dash divided by np, which is equal to tan phi, where phi is the radians. Here phi is very small. Volumetric strain, it is defined as the ratio between change in volume and original volume of the body, and it is denoted by the symbol EV. This volumetric strain is divided into three types generally, that is Young's modulus, modulus of rigidity, bulk or volume modulus of elasticity. In this, Young's modulus is denoted with the symbol capital E, and it is defined as the ratio between tensile stress and tensile strain, or compressive stress and compressive strain. Here, tensile stress is denoted with the symbol sigma T, and tensile strain is denoted with the symbol ET, and compressive stress is denoted with the symbol sigma C, and compressive strain is denoted with the symbol EC. And then modulus of rigidity, here it is denoted with the symbol capital C, N or G, and it is defined as the ratio of shear stress to the shear strain. Here shear stress is denoted with the symbol tau, and shear strain is denoted with the symbol ES. And then bulk or volume modulus of elasticity, it is denoted with the symbol capital K, and it is defined as the ratio of normal stress to the volumetric strain, where normal stress is denoted with the symbol sigma N, and volumetric strain is denoted with the symbol sigma EV. So we came to know about what is strain. Now let us learn what is strain energy. Definition of strain energy is that whenever a body is strained, the energy is absorbed in the body. The energy which is absorbed in the body due to straining effect is known as strain energy. The straining effect generally may be because of three loads, that is gradually applied load, suddenly applied load, or load with impact load. Now, the strain energy stored in the body is equal to the work done by the applied load in stretching the body, and the strain energy is denoted by the symbol capital U. In strain energy, there is only four types of problems, that is strain energy due to bending, and then strain energy due to axial load, strain energy due to shear, and then strain energy due to torsion. Now, how to solve strain energy and deflection due to bending? Let us see the steps first of all. To calculate the deflection under the load in case of beams under the action of point load, that is single point load, means there is only two steps to follow to solve this problem. Step number 1. Calculate the strain energy, that is capital U. And then step number 2, that is nothing but equating strain energy and work done, that is work done is equal to strain energy. So equate strain energy U of the beam to the work done by that load for its gradual movement equal to deflection. Now, let us see the formulas which is to be known to solve the strain energy due to bending problem. To calculate strain energy due to bending, that is U is equal to integral m square divided by 2EI into dx, where U is the strain energy, m is the bending moment, and EI is the flexural rigidity. And then work done. To calculate work done, the formula is that work done is equal to half into W into del, where W is nothing but load and del is nothing but deflection. Now, in order to calculate deflection, deflection is equal to 2U divided by W, where U is the strain energy and W is the load. So, let us see the problems related to strain energy due to bending now. The question is that a beam of span 4 meter, which is cantilever, and subjected to a concentrated load of 10 kilonewton at free end. Find the total strain energy stored due to bending and deflection under the load. Take the flexural rigidity as EI. So, this is the given problem for us. Now, let us see how to solve this problem. So, moving on to the solution for this problem, first let us write the given data. Here they have given that the span, that is the length is 4 meter. So we have to denote length as L. So L is equal to 4 meter. L is equal to 4 meter. Now they have given that it is acting at free end, which is a concentrated load. So 10 kilonewton they have given. So W is equal to 10 kilonewton. Here what we need to calculate? We need to calculate strain energy and then bending. So strain energy is denoted by the symbol capital U and deflection is denoted by the symbol del, and they have given that flexural rigidity as EI, so we are taking it as EI itself. Now let me draw the diagram for this question. That is, first we need to draw a cantilever beam. So I have drawn a cantilever beam here, and then in the question they have given that a concentrated load of 10 kilonewton acting at free end. So at free end a 10 kilonewton load is acting. Then the length of the beam is 4 meter. 4 meter. Now to approach this problem we need to know the moment. So I am just drawing an imaginary line here and just mentioning it as x and x, and let this be the moment point, and let me point these 2 points as A and B. Just for naming purpose I am giving A and B. Now first step to determine U, that is strain energy. We know the formula U is equal to integral m square divided by 2EI into dx. So which is equal to integral, here the distance is from 0 to 4. So the point here we need to write 0 to 4 here, and then moment. We know that moment is nothing but load into distance. As I have taken an imaginary line there, that is xx, the moment will be 10x as load is 10 kilonewton, and I am just taking the distance from that vertical line, that is xx, to the point, that is to the concentrated point load as x distance. so m is equal to 10x. So load into distance, that is moment, so m is equal to 10x here. Now let me substitute 10x in place of m. So 10x the whole square divided by 2 into EI. In the question they have given that to take flexural rigidity as EI itself. So we are just mentioning EI and then into dx. Now let us solve the problem from integral 0 to 4. 10x the whole square, which is nothing but 100x square, divided by 2 into EI into dx. Now we know that in 2 it is divisible, that is 100 is divisible in 2. So integral 0 to 4, 50x square divided by EI. Let me show that in pencil in the above step, that is 2. That is cancelling 100, so it is 50. So 50x square divided by EI into dx. Now I am taking 50 divided by EI as constants and then integral 0 to 4 x square into dx. So which is equal to 50 divided by EI. Here we know that integration x square into dx is nothing but x cube divided by 3. That is a formula. So x cube divided by 3 and it is from 0 to 4. So I am just writing that here. That is from 0 to 4. Now 50 divided by EI. I am just replacing x with 4 and 0 because that is the length of the span starting from 0 to 4. So I am just doing that 4 cube by 3 minus 0 cube divided by 3, just replacing with x. Now 50 divided by EI and then 4 cube divided by 3 minus 0, because anything divided by 0 or cube of 0, we know very well that it is 0 only. So 50 by EI into 4 cube is nothing but 64 divided by 3. Now 50 into 64 is nothing but 3200 and divided by 3 into EI, which is 3 EI. So we have arrived with the strain energy. U is equal to 3200 divided by 3 EI. Now the second step. In second step we know that we need to equate work done is equal to strain energy. So work done is equal to strain energy. Deflection is nothing but change in length, so its unit will be in meter, mm likewise, and the load you know already that it will be in Newton or in kilonewton. Now let me write the work done formula first. Half into W into del, that is the formula for work done. And then strain energy, from the above step we have calculated that it is 3200 divided by 3 EI. Now in this step we need to calculate deflection. So keeping deflection, that is del at one side and moving everything to the right side, so which will be 3200 divided by 3 EI into 2 divided by W. As it is moving on to the right part, it will be in reverse manner. We know that it is just a basic thing, basic max. So 3200 divided by 3 EI into 2 divided by 10. It is because W is equal to 10 kilonewton. They have given it in the question. Now, just cancelling 2 and 10 with the table of 2, it is 1 and 5, and cancelling 5 with this 3200, which is nothing but 640. So del is equal to 640 divided by 3 EI mm. That is the unit for deflection. So we have calculated deflection, and then we have calculated even strain energy. So this is the solution for this question. We have arrived strain energy and deflection for this question. So thank you for watching this video. For more videos, subscribe Learn with Kani YouTube channel, and don't forget to like, share and comment this video. Thank you everyone, and take care.